Hey guys, welcome back to the next video. In this video, we are going to talk about version 1 in terms of how we are normally working with our pods after deploying this from the deployment side. Now, do remember the complications here is that the first complication is that the IP address is not unique. As you can see that the IP address would change every time a new deployment version is released. So that's a headache for you guys because you have to use the for loop, and for loop is definitely not the recommended way to get the IP address because there's a lot of problems. You have to browse this individually. That's a headache. So when you are talking about a live scenario or a kind of like a test and development phase, you cannot expect the developers to access this individual URLs. And also, when you create another update, you're going to get a new individual URLs for each of this pod. That's chaotic. That's impossible for you to manage with the existence of this multi-pod environment. And if it's just 3 pods, then you're going to have 3 IPs. If it's going to be 20 pods, you're going to have 20 IP addresses. That's a huge number of IP addresses, right? So to resolve this issue, we have something called as a service, a load balancer service over here. And here you have the API. The service is the kind. So now it's not a deployment. And the service, the good thing about service is that you can deploy it separately. And this will be a separate YAML file, which will be executed separately apart from your deployment. You don't have to put this into your deployment YAML file or nothing like that. So you can deploy it as a separate service. That's the beautiful thing about this. And the service would obviously have its own name, where here the name is talking about Sterling LB service. So this is going to be, by looking at it, you can see this is for the Sterling application. It's going to be load balancing as a service. And then here you can see, you can also add prod in there, which is a very good thing, saying that this is production load balancer service. So that makes real sense. So when I implement it, I will make it as prod as well. So which just gives you more detail that how important this particular service is. That will actually tell you that when I put that word prod over here as a name. Selector over here on the where the service is going to run. It's going to be on the app Sterling, environment protection, server web. So that's basically is your these guys over here. These pods are your receiver of this service. So that's basically where we are defining it. And then in terms of port, there are 2 ports definition. Actually, there are 3 ports which needs to be defined. The first one is the port of 80, which the service will be actually hosted. This is the local port of 80, which the service will be working on. And the target port is 80, where your containers are running. So basically, the containers are running with 80 port number, right? So you can give that as well as the target port. And next port is host port number. Host port. So host port, as you know, that it enables access from my desktop or from the whole entire world, because that's going to be going out, right? So that's host port. The host port, remember that if you have not defined it, still it will be available. This is it's a range from 30,000 to 32,768. That's the range of this auto assigned host port number. So you don't really have to mention it, but once the service is created, when you just get service details, so there you will see the port number which is assigned for your load balancer. So that's basically it. And then the type of service which you're going to use here is load balancer. So that's basically it. Have given you the explanation over there. You can read it out loud whenever you want to have more understanding on these parameters. Next, you have the architecture diagram. The architecture diagram is so simple that it can be compressed into the small box. I mean, it's not that simple, I guess. But it's a bit complicated, but do not be afraid of this complication, because it's very amusing. It's very good. It's very nice to learn this concept, because it's not something which you learn daily. So what's going to happen here is that when you enable this service, you're going to have another box covering your entire infrastructure. So it is basically wherever you see Sterling Prod Web as a label, right, it's going to cover that. So it also includes master as well. So I'll tell you how. So now that the Sterling LB service, which is also a link group prod over here, so that's basically your service name, and it is hosted on its own port number, which is 80. I've given own so that you can understand that its port number where this Sterling service is hosted is 80, and the target port number is 80. So this is where the containers are running. So you can see the 80 port number over here. So this is where the containers are running. And then you have the node port number. Let's just say, for example, that this is the port number it has assigned. Like 32387 is the port number it has assigned autonomously without we specifying a port number. So that's a port number. So you can see that it's listening on two port numbers now, right? So one is the own port number of 80, which is running on the local IP address segment. So it's just 10.series, 10.250, it would be random. So you can see that 10.105.35.74. It's not the local IP address series, nor it is your the pod IP address. Okay, so the pod IP address is also different compared to the cluster IP address. Cluster IP address will be listening on its own unique cluster IP address, so you don't have to worry about it. So it is taken care by Kubernetes automatically, so you don't really have to, or neither you have a control to change this. So what you need to worry about, or what you need to think about at this moment, is basically your port number 80 over here, which is browsable through this IP address. And there is the node port number. So whenever there is a node port number, what I have told you is that you can use your IP address to browse it. So you can use the 32387 either with your master IP address or your worker IP address or your worker 1 IP address or worker 2 IP address. And this IP address is accessible from my laptop. If it's accessible from my laptop, then it's obviously accessible from the world also. Okay, so because my laptop is my gateway to the world. So if it's like if you're using AWS, GCP, or your own network, you can actually configure external IP address for this, and then you can ask Kubernetes to listen to the world, and the whole world can listen to your Kubernetes by just simply routing it from the DNS or your load balancer, your physical load balancer, to this one over here, and that can actually connect to your your pods which is running within it, right? So now I will also show you how to browse this from my desktop when we do the hands-on, so don't worry about that. So but what I'm telling you is like this service, load balancer service, opens up your pods to communicate further down the line, even though that this is not reachable by my laptop directly. But using this load balancing service, I can actually host the node port number over here. Now, what is the real advantage of this? Let's talk about the real piece of a deal over here. The real advantage where I told you that there is a lot of issues over here, where I have there were two things I told you about. One is about when I create a new replica set, right? So I get new IP address, that's one problem. Second problem I spoke to you about is that when I access this URL, this curl 10.244.3.3:80, it goes directly to this pod. So which means that I don't have one global URL which can connect to all my Nginx servers and give me the output globally. So these two problems I was talking about, both these problems will be resolved with this particular service, load balancing service. How? One thing is that you use any of this IP and port number combination, there's a good chance that it may go anywhere in these three boxes, okay, in these three pods, because this is a cluster IP address. So how cluster is configured using something called endpoints. Now remember, the endpoints are very critical, and it is autonomous. The best thing about endpoints is autonomous, because you're gonna look for, the service will look for these beautiful labels, and then all you have to do is like your deployment should carry the pod templates with these labels, and then it basically takes the IP address and port number, and then it puts it across as endpoints. That's the first one. So first problem is, I think I addressed the second problem, which is like accessing one URL and then you kind of go everywhere. If all the ports, you access all the ports with one URL and one port number, right? So that problem, the second problem is addressed. The first problem is like, if I create another deployment or update the existing deployment, and I kind of have a newer version of, newer versions of the replica set created. Now, what will happen to the new IP address? That's where the beautiful thing called selector comes in. So as you create a new deployment and a new replica set is created, a new pods are created now. Let's just talk about, let's forget fixed. Well, you put it any deployment strategy. You go for fixed or you go for like a rolling update. The moment a pod is released with this label, then obviously it's going to connect to that and it's going to establish this. But do remember one thing, it's always nice because I think in rolling update, when we looked at it, right, we didn't use the readiness probe. It is always advisable to use a readiness probe, because in this situation where the load balancer will look for the labels but not the readiness, because the readiness is responsible of the pod when it starts up. So I have already explained you previously on the fixed update how important is readiness. So you have to think very much on the readiness towards understanding completely about this particular concept of a service or a load balancer. So the readiness helps you to establish the IP address once the readiness has succeeded, the condition of readiness is succeeded. So that is something you should remember before you configure this kind of a service and then affiliate it to any kind of a deployment which you already have. All right, guys, so I think so much has been spoken in this video. I hope that you understood what is a service like a load balancer right now. I've just gone through the basics of it. The advanced concept is a little more information, but then it's not something very hard for you to understand. If you can understand this, I'm pretty sure that you can understand that as well. Thanks again for your time. And there's obviously options to verify your service. There's option to verify your endpoints. There is options to verify your pods, your containers in a pod, and all those things we will talk later on our hands-on session. Thank you again for watching this video. See you on the next one.